Lewis Hamilton has just stunned Ferrari fans around the world after delivering a devastating message following one of the most painful weekends of his entire career, a weekend where he started last on the grid and learned that the Ferrari SF25 simply could not give him the tools to fight. According to the race data, Hamilton began the Las Vegas Grand Prix in 20th place after losing more than 9 seconds in qualifying due to freezing conditions and tire temperatures that never entered the proper window, trapping him behind 19 cars on one of the toughest circuits for overtaking. During the race, he fought his way to 10th, but finished almost 60 seconds behind the winner because the Ferrari SF25 never warmed its tires. The car slipped in the slow corners, understeered through the medium speed sections, and forced Hamilton to manage survival instead of racing for points. And before I reveal the exact message Hamilton sent to the Tifosi after crossing the line, make sure you subscribe right now, because what he said exposes a deeper crisis inside Ferrari that could define the final 2 races of the 2025 season. Hamilton's difficult weekend began long before the lights went out in Las Vegas. Ferrari's internal data revealed that the SF25 struggled immediately during qualifying when the track temperature dropped sharply and the tires refused to reach their ideal working window. Instead of gaining grip with each lap, the rubber cooled further as the session progressed. Hamilton had no front-end bite, no rear stability, and no ability to lean on the car during turn-in. When the qualifying sheets closed, he was more than 9 seconds off where he needed to be. This result locked him into 20th place, placing him at the very back on one of the least forgiving circuits for recovery drives. From the start of the race, Hamilton sensed that the situation had not improved. The tires still sat below the temperature threshold required for mechanical grip. Each time he attempted to push, the front slid across the asphalt, causing the car to lose rotation through the slower corners. The SF25 demanded a level of grip that the Las Vegas surface simply did not offer under those conditions. The telemetry showed him fighting to stabilize the car rather than drive aggressively. These limitations created a race where Hamilton had to manage weaknesses instead of attacking opportunities. The gap to the midfield increased steadily as the tires refused to respond. The street layout of Las Vegas intensified every flaw. Cold air circulated through the canyon of buildings surrounding the track, draining heat from the tires quicker than Hamilton could build it. The long straights reduced load on the tires, preventing them from generating fresh energy. Meanwhile, the slow corners demanded bite and rotation, 2 qualities the SF25 could not offer. Ferrari's engineers confirmed that the car's balance shifted unpredictably, with the front axle failing to connect fully to the asphalt. Hamilton felt this unpredictability in every braking zone, forcing him to drive with caution rather than confidence. As the race continued, these issues compounded. Whenever Hamilton approached traffic, the turbulent air from the cars ahead stripped more temperature from the tires. This placed the Ferrari in an even deeper performance deficit. The team saw clear evidence in the data that each time Hamilton closed in on a pack, the tire surface cooled by several degrees, causing immediate understeer. The loss of heat forced Hamilton to back off to rebuild temperature, a process that cost him time every lap. The difficulty was not the pace of his competitors, but the inability of his own car to maintain consistency across changing airflow conditions. Ferrari attempted to adjust the strategy to help Hamilton stabilize the tires, but nothing changed the fundamental behavior. Whether on higher fuel or during the lighter final laps, the SF25 refused to reach the working range necessary to generate confidence. Hamilton reported that the rear axle felt unstable on throttle application and that the car lacked the connection to the road required to push through medium-speed corners. The problem was not a momentary imbalance. It was a structural mismatch between the car's setup and the environment. The colder it became, the worse the SF25 responded. By the final laps, the full scope of the damage became clear. Hamilton finished 10th, nearly 60 seconds behind the race winner, not because of mistakes, but because Ferrari never placed him in a car capable of fighting. The data confirmed that the tires never once reached optimal temperature during the entire Grand Prix. This is why his post-race message to the Tifosi carried such a heavy tone. The story was not about strategy or overtaking difficulties. It was about a car that never entered its performance window. The gap between potential and reality became impossible to hide, and Hamilton chose to speak frankly about it after crossing the line. The core problem behind Hamilton's painful weekend became impossible to ignore the moment Ferrari examined the qualifying analysis. The SF25 failed completely to build tire temperature during the decisive laps, leaving Hamilton with no grip to fight the cold Las Vegas surface. The compound remained below its operational threshold from a moment he left the garage. Without heat, the front tires refused to bite into the asphalt, and the rear tires did not provide the traction needed for acceleration. The result was a qualifying lap where Hamilton spent more time managing instability than pushing for performance. This placed him in 20th position before the race even began, and that single outcome shaped every challenge that followed. As Ferrari studied the telemetry, they discovered that the problem extended beyond tire temperature alone. The aerodynamic profile of the car did not adapt to the sudden drop in track temperature. The SF25 relied heavily on a predictable level of downforce to stabilize the front axle during turn-in. However, the cold surface offered none of the grip the car expected. This meant that Hamilton entered corners with a car that felt disconnected from the road. Every time he turned the wheel, the front slid further than intended, delaying rotation and forcing Hamilton to adjust his lines. This behavior was not a matter of driving style. It was a fundamental mechanical limitation that prevented him from performing at his usual level. Another major factor emerged from the way the SF25 distributed energy through its suspension. The data revealed that the damping characteristics were tuned for warmer conditions and smoother surfaces. As the Las Vegas temperature dropped, the suspension failed to deliver the vertical load needed to activate the tires. Instead of pressing the compound into the track surface with consistent force, the suspension allowed micro movements that drained energy from the rubber. Hamilton felt this throughout the lap, especially in slow corners where the car hesitated to generate grip. Ferrari recognized this as a design mismatch between their baseline setup and the extreme cold of the night race. Traffic made the situation significantly worse. From 20th place, Hamilton was forced to follow cars that created turbulent air, which further reduced the aerodynamic stability of the SF25. Turbulence disrupts the airflow feeding the front wing and reduces downforce at the very moment the tires require maximum load. Ferrari's data showed that each time Hamilton approached a group of cars, the tire surface temperature dropped even further. This trapped him in a cycle where he needed to attack to gain positions but lacked the grip to do so. Every attempt to close the gap resulted in more tire cooling, creating a barrier he could not overcome. Ferrari also identified problems with how the car handled energy transfer during corner exit. With cold tires, the rear axle did not provide the traction Hamilton needed to accelerate efficiently. As he applied throttle, the tires slipped rather than digging into the surface, causing small losses that accumulated across the race. This made the car feel inconsistent and unpredictable during acceleration. Hamilton had to adjust his driving to prevent excessive wheel spin, which cost him speed on the straights. Ferrari's engineers reported that these corrections, although necessary, slowed his progress dramatically and made it impossible to catch the midfield. The final and most damaging element in the problem was the complete absence of tire activation across the entire Grand Prix. Ferrari confirmed that the SF25 never reached the ideal temperature window for either stint. Even on lighter fuel, the tires ran several degrees too cold to generate competitive grip. This meant that every corner required Hamilton to operate below the natural pace of the car. He was driving within the limit of the tires rather than within the limit of his own ability. This is why Hamilton's post-race message shocked the Tifosi. He explained that the car never entered its performance window at any moment, leaving him powerless to fight for more than a single point. It was not a story of errors. It was a story of a car fundamentally out of sync with its environment. Ferrari engineers knew immediately after the race that the SF25's tire activation problem required a deeper investigation than a simple setup misjudgment. When they analyzed the data stream from Hamilton's first stint, they noticed that the tires reached a stable but completely inadequate temperature plateau within only a few laps. Instead of climbing toward the ideal operating window, the heat levels flattened far below the target range. This created an engineering paradox. The car was generating enough load to maintain motion, but not enough energy to build temperature. Every corner Hamilton took fed too little friction into the compound, leaving the car stuck in a state where grip could not increase no matter how cleanly he drove. The suspension system became one of the first components Ferrari examined. The SF25 was designed to work with a precise rhythm of compression and rebound that helps transfer heat into the tires during acceleration and cornering. But the Las Vegas surface, shaped by temperature swings and inconsistent grip patches, prevented the suspension from working in harmony with the tires. As engineers reviewed the load distribution graphs, they found that the suspension delivered energy unevenly. In warm races, this rhythm helps the tire expand and dig into the asphalt. In Las Vegas, it simply dissipated the energy before it could be absorbed. This left Hamilton fighting instability he could not anticipate or correct during the race. Aerodynamic consistency was another major weakness exposed by the cold desert night. Ferrari's aero map for the weekend was built for a specific airflow behavior, which assumes a minimum level of tire temperature. When that temperature never materialized, the aero platform produced less downforce than expected, especially on the front axle. Telemetry from Hamilton's laps showed that the front wing could not create the pressure needed to stabilize turn-in. Without this fundamental balance, the car felt reluctant to rotate and left Hamilton compensating with steering corrections that drained what little tire temperature he had. This mismatch trapped him in a cycle of understeer that became more severe with each lap. The power unit also played a subtle but important role in the performance collapse. Ferrari engineers observed that the torque delivery, normally smooth and predictable, became much harder to manage on cold tires. Whenever Hamilton applied throttle at corner exit, the tires failed to generate the traction required to translate engine output into forward momentum. This caused minor slides that destabilized the rear end and forced Hamilton to ease onto the accelerator rather than attack with confidence. Engineers confirmed that this behavior cost him several tenths per sector. It was not a matter of power, but of the car's inability to deliver that power to the track under the extreme conditions.